Hello, in this video we're going to look at solving trigonometric equations when you need to use a quadratic formula to solve it. So here's our example. Cosine 2x equals 2 cosine x. Now as I look at this I can see that I have probably to use an identity because I have a double angle here and a single angle there. So I'm going to go ahead and use one of my handy dandy identities that I know so well. Now, since I have cosine of a single angle here, I probably want to choose the form that has the cosine of the single angle, even though it's the second power. So I'm going to choose this one here, so I don't have to have two separate trig functions. So I'm going to say, instead of cosine 2x, I'm going to work with 2 cosine squared x minus 1 equals 2 cosine x. Right? Now, from here, I realize I have a second power, then I have a first power, and then a constant. So it looks like a trinomial. I would want to move everything to one side and have the other side equal to 0 and see if I can factor. Okay, so now when I go to try to factor, I'd say 2 cosine x, I'd have a 1 and a 1. At this point, since I have a negative here, I'm either going to have this be positive and this be negative, or this be negative and this be positive, right? So if I try both combinations, here I have the 2 cosine x squared, that's fine, and I'd have the negative 1. But it's this middle term. I'd have a, if I use this bottom one, I'd have a positive cosine x and a minus 2 cosine x. That'd just be a minus cosine x, not minus 2 cosine x. If I use the top combination, I'd have positive 2 cosine x and a minus 1 cosine x would give me a positive 1 cosine x, not a negative 2 cosine x. So I know here I can't really factor this, so I'm going to have to use the quadratic formula. Now, if I'm going to use the quadratic formula, I'm going to let t equal cosine x, just so you can see the form a little bit better. So that means here, if I rewrite this, I'd have 2t squared minus 2t minus 1 equals 0, right? So instead of writing cosine x, I write t. So here I have t squared minus 2, so 2t squared minus 2t minus 1, all right? Now, here that means this is a, this is b, this is c. So a is 2, b is negative 2, c is negative 1. And that means I'm solving for t using the quadratic formula. I have negative b plus or minus square root of b squared minus 4ac all over 2a, right? So now, plugging in, I would have t equals negative of a negative 2 plus or minus square root of, now the b squared would be the negative 2 squared, minus 4, and I already go ahead and give myself parentheses all so that I make fewer mistakes. So a is 2, c is negative 1, and here a is 2 again. All right, so now when I start to simplify, I have a negative times a negative is a positive, right? So it's a positive 2. I don't have to write the plus, but it's just so that I, again, make fewer mistakes. Plus or minus, now negative 2 squared is 4. Then I have minus and a minus. So negative times a negative is going to be a positive, and 4 times 2 is 8, times 1 is still 8. All over 2 times 2 is 4, okay? So now what I have is t equals 2 plus or minus. Now here, when I do 4 plus 8, I know I'm going to have square root of 12, right? Which when I factor it, it's 2 times 3, right? 4 times 3. So this can come out, and I really have 2 times the square root of 3, right? So I can write this as 2 plus or minus 2 times the square root of 3 all over 4, all right? So now, let me go ahead and write this up here. So I have here t equals 2 plus or minus 2 square root of 3 all over 4, right? And now, essentially, I can work on these separately. T equals 2 plus 2 square root of 3 over 4, or t equals 2 minus 2 square root of 3 over 4. Right? Now, When I go ahead and put this in my calculator, I should get t equals, let's see, 1.366025. And here I'll get t equals negative 0.366025. Okay? But now remember, we did a substitution. I let t be cosine x. So I'm going to now resubstitute and say, well, this is really cosine x. And this is also cosine x. Okay. Now, hopefully I recognize right here that cosine, the range of cosine never exceeds 1, so it can't be 1.366025. So if you have to, then you might have to put it in your calculator if you forgot. Right? And you'll get an error, so you'll know that there's no solution here. Okay. Now here, when you say, oh, okay, x is the inverse cosine of negative 0.366025, okay, here what you'll get is that x is 1.94553. So that's the angle. So now you're saying, okay, where, so this question asks for what angle, right? The theoretical question asks for what angle between 0 and pi is the x-coordinate, because we're talking about cosine, a length of negative 0.366025. So that means I'm going in the negative direction, a length of 0.36625. So I'm somewhere here, and the calculator tells me that x is 1.94553. Okay, so there's my angle. I swung out. I rotated that way, right? Here's my reference angle. Now, where else on the unit circle do you have an x-coordinate of this length, negative 0.366025? Well, right down here, right? So you also have the negative of the angle. So you have negative 1.94553. Okay. So now some people don't like to leave this as a negative. You could also say go 2 pi and then back up negative 1.94535. So if you like that, you could say 2 pi minus 1.94553, and basically you'll get 4.33765. You can do it that way. But now what I've got are my two solutions here and here. If I want the infinite generators, I'll have x is 1.94553 plus 2k pi, and x equals, we'll use this one, 4.33765 plus 2k pi. Okay? Thanks so much for listening.